We have discussed last time. We started talking about the memory hierarchy in cache, and in the memory hierarchy, we talked about that the memory is distributed into different levels. So it's not a single memory. The memory is divided into different categories, the smaller memory and the larger. So we talked about that we will be focusing on two level memory. So the memory that is closest to CPU, what is it called? It's a cache, right? And as I mentioned, memory is arranged in multiple levels. The memory closest to CPU is called cache, and data is arranged in the form of blocks, both in the main memory and in the cache memory. And we were talking about the direct mapping strategies, which means that whatever the block size in the main memory is, it will be the same size in the cache. So for example, if a certain block like this one, so this one, if it is copied into the cache, whatever the size of the block here, let's say it's 1 word or 4 words or 8 words, it will be the same in the cache. Okay. So how do we distinguish, like how do we place the blocks in the cache? So comparatively, main memory is larger in size than cache. So how do we plot it? So first of all, in this example, we have a cache of how many blocks are there in the cache? There are 8 blocks in the cache, and we can map each block with the help of like 3 bits. So 8 blocks means, like if you were to write it in the power of 2, 2 to the power 3 corresponds to the value 8. So we can actually use 3 bits, 3 lower address bits of the memory address to map the block from the memory into the cache. So we use lower order address bits to index the block in a cache. So here 001 will map to this block in a cache, 001. Similarly, this one also 001. So if this data is missing in the cache, this block will replace this block here. Okay. So if initially we had this data placed here, and when this data is requested by the processor, this block will override the data that is already placed here, which belongs to this block. Okay. Same is the case with here 1000001 and 11001 and so on. How do we recognize whether the data present in the cache, let's say this one, the data present in the cache belongs to this block or this block? Let's say if it belongs to address memory address 1 or memory address 9 or memory address 17 and so on. How do we distinguish that? With the help of tag bits. So what are the tag bits? The upper or the higher order bits memory address in a memory address. Okay. So we store these bits in the cache also. Instead of storing the entire address, what do is we store the upper level bits or higher order bits of the memory address, which we call tag bits. We also store one additional bit with each block to indicate if the data is valid or invalid. Okay. So if I have to map a block into this cache, map a block of memory into the cache, this is the general formula. So block number in the cache, and this is what we will be practicing with today also. And you also need this formula to complete your assignment, the last question 8. So you need to determine which block the address will be mapped into the cache. So block number in a cache, it is determined by the block address in a memory, whatever the address being requested from the memory, and modulo the number of blocks in the cache. So we will practice that later today. But before that, just a quick recall that we discussed this example. In this particular screenshot here, I have taken an example when these 2 locations in the memory in the cache has already been populated with some data by the previous calls. So suppose that if this data is called again, so let's say the processor requests a data, let's say placed at address 22 with the help of LW instruction. So how does it check into the cache first? So it splits the data into these bits. So lower order 3 bits are checked first. So let's talk about the 26. So these are checked with the data in a cache. So this particular block will be checked, and these tagged bits will be matched. So this is the complete address. You will check it with if this is present, and if the data is valid, then it is a case of hit. It's a cache hit, which means that the data that processor requests is found in the cache. It does not need to fetch the data from the main memory. Okay, so that is what we call the cache hit. And this is also have been requested in your assignment, that you need to identify whether the certain request of the data is a cache hit or a cache miss. Let's see this example here. When this request the data is requested 18, so lower order bits are same as of this one, 0, 1, 0, but it also needs to match the tag bits. So here the tag bits does not match. That is why it is considered as a cache miss, because the data placed at this location is something different than the requested data. So it has to go to the memory and fetch the data from there and then place it here. Okay? So do you understand what is hit and miss? Yep.
So just to clarify, this is when you're first initializing it and then hit when you.
So miss is when the requested data is not found in the cache.
Yeah, and then you put it in there, right?
So we need to put it fetch from the memory. Lower level, we need to go to the lower level of the memory hierarchy and then fetch the data from the memory and put it in the cache. Yes.
So basically, if you don't find it, does it automatically put it back into the cache so you could try to find it in another iteration, or is it like?
No, then we need to stall the cycle actually. So processor, when it does not find the data in the cache, then it has to fetch it from the memory. For that, it has to stall the cycle. Okay. But we are not going into that details of how that happens.